Okay, so today's lesson is going to be on perpendicular and parallel lines and their equations. All right, so the first thing that we need to do is we need to get some definitions down. All right, so what are parallel lines and what are perpendicular lines? Well, parallel lines are two lines that never ever intersect. Okay, so here is our example right here of parallel lines. All right, you can see that they never intersect. The number one thing you need to learn, all right, about parallel lines, and I would make sure that I write this part down, parallel lines, they have the same exact slope. Okay, so it doesn't matter if their slope is going up like right here, or if their slope is going down like right here. They have the exact same slope. So this line and this line are sloped the same. Okay, in perpendicular lines, all right, those are just two different lines that intersect at a 90-degree angle. And you can see these right here, these two lines intersect at our 90-degree angle. All right, we know that that box means 90 degrees. So that means all of these are 90 degrees. 90 degrees, 90 degrees. Okay? And in particular, they have slopes that are opposite reciprocals. Okay, so their slopes are direct opposites of one another. Okay, so we're going to look at some examples here. So look at our first example. This is example 1. So I have two lines drawn. All right, obviously right now you can see that these are parallel lines. They are parallel because they never touch. All right. And what can I see in these parallel lines? The equations of these two parallel lines. All right, well, obviously you can see that this red line, all right, the red line is y equals 2 over 3x plus 1. The blue line is y equals 2 over 3x minus 2. If you go back to your Algebra 1 days, y equals mx plus b. All right, you'll remember that your slope is your m value. Okay, your slope, your rise over your run. Okay, it's the rise, the change in the y values over the change in the x values. All right, so whatever is right there next to that x, all right, that's going to be our slope for these equations. Okay, so in both of these things, all right, the red, what is our slope here in the red? Our slope is 2 over 3. And in the blue, our slope is also 2 over 3. Because both of these are the exact same, I can say that my lines are parallel. And this, this picture right here really does a good job of proving that for us. Okay? Now let's look at another example. Okay, here in this example, you can see that, again, we have two lines. We have a blue line and a green line. And it appears that we have a 90-degree angle here in the corner. All right? So what we're going to do, it appears that these are perpendicular. But what we need to do, all right, perpendicular just means lines that intersect at a 90-degree angle. So what we need to do is we need to look at their slopes. So what is the slope of the first line? All right, I'm going to look here at our slopes. Remember, slope, y equals mx plus b, where m is our slope value, the rise over the run, the movement that we have. Okay, and here this first one is 1 over 3. In the second one, it's negative 3 over 1. So if I look at those two side by side, all right, the things that I notice about them is that they are exact opposites of each other. One is positive 1 over 3, and the next is negative 3 over 1. And because they are exact opposites, all right, a special word in math is called opposite reciprocal. So anytime I have this opposite reciprocal relationship within my slopes of lines, I'm always going to have perpendicular lines. Okay? Okay, now in this example, we're going to actually determine if these lines are parallel to each other. So parallel, all right, I'm starting here, and I know something specific about parallel lines. I know that if I write these out and I put them in mx plus b form, all right, y equals mx plus b, I know that in both of these lines, for them to be parallel, I have to have the same exact slope. Okay, so right away you can look at yours and say, well, hey, there's one's 2 and one's 4, all right? But not so fast, all right? It's not exactly that easy. What we need to do is we need to solve these for y, okay? These are not solved for y by themselves just yet. So we need to kind of do some moving around, and we're going to figure out how we can actually determine what these slopes are. All right, so we're going to do that here very, very, very quickly. Okay, so let me rewrite this. We got 2x plus 3y and 4x plus 6y. So if I take my first equation, 2x plus 3y equals 9, and I'm trying to solve this for y. I'm trying to get y all alone by itself over here. Well, the first thing I notice is I need to move this 2x over here to the other side. All right, I do that by subtracting 2x. Now, the problem with taking 9 minus 2x is those aren't like terms, so I have to keep those things separated. So here I have 3y is equal to negative 2x, and then I have plus 9 just stuck kind of on the end there. Okay, I still don't have y all alone by itself. I have 3 times y. So what I need to do is undo that multiplication by dividing everything in here by 3. All right, now I have y equals negative 2 over 3x plus 9 over 3, or 9 divided by 3 is actually just 3. Okay, so this one is done. It is worked out. I've got it in y equals form like we said that we needed. Now let's look at my second one that I have. Okay, I have 4x plus 6y equals 12. All right, I need to figure out if these are parallel, so I need to figure out what y is equal to there at the very end. So again, the same exact process. I'm going to move my 4y over by subtracting it. So I have 6y is equal to negative 4x plus 12. And again, I haven't gotten y by itself just yet. I need to divide both sides by 6. Okay, when I do that, all right, I get y equals negative 4 over 6, which will simplify. 4 over 6 will simplify to be negative 2 over 3x plus 12 over 6 is 2. Okay, now I've got it in that form. So what do I notice? All right, I'm going to examine my two slopes. Negative 2 over 3, negative 2 over 3. So because those both have the same slope, all right, we can say that these two lines are indeed parallel. Okay, so I can say that these are parallel. All right, let's look at a perpendicular problem.